Session is being recorded. So yesterday we were talking about the two different strategies of inheritance mapping. Initially, the very first strategy that I discussed to you, it was single table strategy. This is actually referred as table per class hierarchy. When I was talking to you about the table per class hierarchy, at the time I told you that for the entire hierarchy, there will be only a single table, such that the single table is containing entity from the parent class, the same table is containing entity from first subclass, the same table is containing data from the second subclass. Everything is going to be available in the same table. And because everything is available in the same table, so definitely your single table is going to be slightly bigger. But if I'm talking about the join operation or the union operation, then definitely join operation and union operation, they are not required. On the other hand, if I'm talking about because a single table is containing data of the subtype and there can be multiple subtypes available. So yesterday we have seen that there is one column created such that the name of the column is referred as D type column. By default, the retype column is of string type and the retype column is containing subclass name as a discrimination value. If you wanted to change the name of the discriminator column, then definitely you can change the name of the discriminator column also, as well as you can change the data type of the discriminator column also. For every subclass, if you wanted to specify some non-default value, then to specify the non-default value, you have to use @discriminator value annotation at the top of the subclass. Regarding the same, an example yesterday we have already taken yesterday. If you remember yesterday, I was talking to you initially that there is a class available such that the name of the class is called human class. And if I'm talking about the human class, on the human class, the strategy is @inheritance strategy equal to inheritance type dot single table. Discriminator value, discriminator column we have mentioned, discriminator type we have mentioned, and definitely this is a normal class. If I'm talking about its subclasses, then one of the subclasses is student class. Another subclass is also available. The name of the class is employee class. You can see there is an annotation available. The name of the annotation is called @discriminator value. The name of the annotation is called @discriminator value annotation, such that the @discriminator value annotation is actually responsible for giving a new name. And if I'm talking about the table structure, then you can see that yesterday we were talking about, let me take the database name from the persistence.xml. Into the persistence.xml from the URL property, you can say that name of the database is inheritance mapping Hibernate. So let me come to MySQL once. I am on the MySQL, then writing using the same database. Thereafter, I am talking about show tables. Thereafter, I am talking about first table. The name of the table is called human table. Then here I am writing that is select star from human semicolon. So you can see into the human table, type column is available such that the type column is actually responsible for specifying what specific type of entity it is. If I'm talking about one of the limitation, then definitely if I'm talking about the subclass column, then definitely all the subclass column must allow null value. You cannot write down not null for them. Simple logic it is. Why you cannot write down not null for them? Because sir, if we are saving the employee entity here, if we are saving the student entity here, then definitely for the employee entity, all the columns of the student entity will have null value. Similarly, for the student entity, all the columns of the employee entity will have null value. So all the subclasses, all the attributes of the subclasses, they must allow null value. We cannot make them not null. Getting my point, everybody? This was the first strategy. Those who have done some assignments, those who have done the revision, for them, definitely it's a bonus thing. Yeah. Then I'm talking about the second strategy. The second strategy is available that is called the join table strategy. The join table strategy actually used to say us the one thing that there is a separate table available for the superclass. There is a separate table available for the subclass, and the superclass and subclass, they are available or they are actually combined using simple join operation. And definitely, if you are performing a join operation, and in this condition, if I'm talking about the time required to fetch the data, then definitely the time required to fetch the data will be higher. Make sense? Simple logic. Join operations are always costly. So this is the one point that actually you have to take care. Yesterday, we have taken example And if you remember the example, then I was talking to you about one class. The name of the class that we were calling is science student. And if I'm talking about the class science student, it is containing ID, physics marks, chemistry marks. To specify the inheritance strategy join, we have to write down @inheritance strategy equal to inheritance type dot join. Then actually you can see that one subclass I have created, this is math student. Another subclass that we have created is bio student. One more thing available, @primary key join column. This is used to override the name of the foreign key column in the subclass. The default value is ID. If you wanted to use some other name, then definitely you can use the same. So right now, simple. One class is available, science student. In the science student, you can see that there is ID, physics marks, and chemistry marks is available. Because in the join table strategy, for every class, there is a separate table available. So can we say that one table will be created science student? In the science student table, there will be 3 columns available. The first column is ID, the second column is physics marks, and the third column is chemistry marks. Yes or no? Then if I'm talking about the next class, that is math student, because math student is a subclass of science student class. So here again, you can say that a separate table will be there. In the separate table, there will be 2 columns available. One column is going to be math underscore student underscore ID, and second column is going to be for the math marks. And definitely the math underscore student underscore ID is working as a primary plus foreign key in this table, and it is referring to primary key of the science student table. The same thing is applicable for biology student also. For the biology student, one table will be created. The first column is going to be bio underscore student underscore ID. The second column is going to be bio underscore marks. And then actually you can see into the app.java, we are actually adding the things one by one. And yesterday we have seen the example also that it was working fine. I think this I have opened the wrong file, app.java. Yeah, this one is a better file. Default customer is not required now. Yeah, app.java is opened here. Into the app.java, save human type, save human and show human and types, then definitely save science type, etc. This is something we have done. If I'm talking about the table structure, then from the show table, you can see that one table is available. Name of the table is called science student. Another table is available. Name of the table is called math student. And one more table is available. The name of the table is called bio student. So for example, let's say that if I am writing here the point that is science student. So definitely first is available to you. Then the next point we are writing is going to be math student. And the third thing that we are writing is going to be bio student. This is created. Thereafter, if I'm writing the query that is select star from science student semicolon, then definitely you can see that we are having 4 student, 1, 2, 3, 4 is their ID. Then if I'm writing the query that this is going to be select star from math student, then we are writing the next part. This is going to be bio student. So here you can see that first 2 scholars, they belong to mathematics. And if I'm talking about the last 2 scholars, then definitely the last 2 scholars actually belong to simple biology background. Then actually you can see here that so much methods are there. Particularly, what is my target to show you? Definitely, if I am talking about the show science type method, then in the show science type method, you can see that we are writing select S from student, science student S. Let me once run this code. Let me once run this code. And hello, Mr. Hibernate, what happened? Yeah. Specifically, everybody, I am asking you to focus on this query that initially I am writing on Notepad. The query is select s1.id when something is available. But if I'm talking about the main portion, then into the main portion, can you see this word? Left join. So same thing that I was telling you, that in case of joint table strategy, because different tables are created, and whenever you are writing the select operation, then for the select operation, it is going to use join operation. That's why its performance is going to be slower. Verified? Yes or no? Everyone verified? Yes or no? What happened? Only 1 or 2 scholars are replying in the batch. Don't sit idle. This is just a repetition. Now, two strategies we have covered so far. Then I'm talking about the remaining two strategies also. So listen, if I'm talking about the third strategy, then the third strategy is referred as the table per class. If I'm telling you the easy way to remember this, then this is going to be table per subclass actually. Again repeating, the formal name of the strategy is called table per class. But if I'm talking about the actual name of the strategy, then definitely for the sake of easy remembrance, you can remember it like table per subclass. And see, when I'm talking about that it is table per subclass, then definitely it is very easy to say that there is no table for the superclass, but separate tables will be created for each subclass. Getting my point? Simple logic. There is no table for the superclass. Separate table will be created for the subclass. And definitely when you are creating separate table for every subclass, then attribute of superclass will be repeated in multiple tables. Getting my point? Why multiple tables? Simple logic. Simple logic. So you can see the strategy actually says that table are created for each concrete class in the class hierarchy. Contrary to join table, a table is created for superclass if it is concrete class only. No table will be generated for superclass if it is an abstract class or interface. For this strategy, the annotation that is to be used for the superclass is inheritance strategy equal to inheritance type dot table per class. Second point, this time see, just a simple example. Let me take a very simple example here that will actually help you. So I'm going to day number 15. On the day number 15, I'm talking about the strategy that is called table per class strategy. And table per class strategy is something you can remember as table per subclass. This is actually just for remembrance. So let me say a very simple example. For example, let's say that I am having a abstract class, and let's say that name of the abstract class that I am writing is electricity connection. Whenever we are talking about an electricity connection, then definitely there is unit consumed and there is unit charges. These are the two things that we have to take care. So for example, let's say that I am writing here that is private integer, and one variable that I'm talking to you is unit consumed. Let's say that it is per month. Then I'm talking about the next part. Then definitely the next part is going to be private double. And after private double, then we are talking about, let's say that unit charges. And definitely this class is going to be an entity. And because this class is turning into an entity, so definitely it is good to use at the rate ID annotation. And here actually I am writing private integer ID. This is a simple superclass. This is a simple superclass. Rest of the data is available there. Thereafter, I'm talking about its one of the subclass, and name of the one of the subclass I am writing is, let's say it's turning into domestic electricity connection. The domestic electricity connection actually extends the electricity connection class. Now into the electricity connection class, let's say that being as a domestic user, number of taxes are very less and number of taxes are very less. So for example, let's say I am writing that we have to pay only electricity duty only. There is only one tax available, that is called electricity duty. Second thing, I am writing about one more type of connection, and this one more type of connection is actually referred as the commercial electricity connection. And because you are a commercial electricity connection user, so in this case there is one more tax available. The name of the tax is called value added tax, that is also referred as the VAT. And apart from the value added tax, there is one more charge available, and this charge is actually we can call the fixed charge per month. So listen, first of all, the superclass is an abstract class. Yes. Second thing, if I'm talking about the inheritance strategy, so the inheritance strategy, let's say that I am providing is, it's going to be inheritance type dot table per class. Question number one, will there be any table for electricity connection? Question number one, will there be any table for the electricity connection? Answer is no. Because in case of table per class strategy, the exact name I was telling you is table per subclass. In this strategy, only actually table will be generated for subclasses. no table will be actually generated for the superclass, especially if it is a abstract class. Getting my point? That no table will be generated for the electricity connection. First pointer clear? Yes, it is. Now, if I'm talking about the table, that how many tables will be generated? So simple logic, there will be two tables generated. If I'm talking about the first table is going to be domestic electricity connection. Into the domestic electricity connection, first variable will be ID. Second column is going to be unit consumed. Third column is going to be unit charges. Fourth column is going to be election duty. Sorry, electricity duty, not election duty. Similarly, if I'm talking about the next table generated will be commercial electricity connection, and definitely first three attributes are as it is. Then if I'm talking about value added tax, it will be added. Apart from the value added tax, fixed charges will also be added there. So getting my point, how the table structure will be? Yes or no? Yes, it is. So this time, can I say that column of the superclass is repeated again and again, two times? Yes, it is. Okay. So this is table per subclass strategy. Then everyone, if I'm talking about saving the data, then definitely saving the data is not a big deal. Saving the data is not a big deal. But if I'm talking about big deal, so for example, let's say everyone, if you are using the reference variable of, or let's say that you are writing the JPQL statement. Into the JPQL statement, for example, let's say that you are writing select electricity connection, EC from electricity connection. So this time, practically, there is no table for the electricity connection. Yes or no? Everyone, practically, there is no table for the electricity connection. So actually what will happen, if I'm talking about this query, then this query will actually fetch data from both the tables. So if I'm talking about the first table, that is the domestic electricity connection, and it will fetch the data from the commercial electricity connection also. So can I say this is kind of polymorphic behavior, that practically we are using superclass, but it is fetching data from the subclass also? Second number point. Second number point. See, ID is available here also, and ID is available here also. So simple logic, just actually try to understand. When I was talking to you about the joint table strategy, in case of the joint table strategy, if you remember the database structure, then can I say, sir, in case of the joint table strategy, practically there is no ID for the subclass. They are sharing the ID from the superclass. Yes or no? This is example of joint table strategy in which the subclass does not have any identity column. The subclass is actually sharing the identity column from the superclass. But if I am coming back to the table per class strategy, this time there is no ID available for subclass. So can I say that every subclass is having its own different ID? Yes or no? Yes, it is. And definitely, if every subclass is having its own different ID, and let's say that you are firing this query. So in this condition, don't you think that very high chances are there that two different objects with same value for ID column can be there? Yes or no? Simple logic. When you are writing this query, then possible chances are there that you can have two or more different entity object into your persistent context that are having same value for the ID column. Is it okay to have the more than one object with the same ID column? Is it acceptable in the persistent context? Answer is no. So can I say that practically it is the responsibility of the programmer to manage the identity conflict? Yes or no? Because practically it is responsibility of the programmer. That's why in this case, Hibernate only says one thing to you, or the ORM says only one thing to you. It says that you cannot use the generation strategy, that is generation type dot identity. Getting my point? You cannot use the strategy generation type dot identity. Why? Because there are two different tables. When there are two different tables, so Hibernate is not capable to ensure that two different table must have distinct set of IDs. Because according to MySQL, commercial electricity connection is one table. For this, if I'm using it auto increment, then its ID will be 1, 2, 3, 4. MySQL says that I used to maintain the auto increment at the table level. Hibernate, if you are maintaining some relationship, it's your headache. So according to MySQL, into the domestic electricity connection, there can be an entity whose ID is 1. into the commercial electricity connection, there can be one record available whose ID is 1. According to MySQL, there is no error, but according to Hibernate persistent context rule, this is not allowed. Getting my point? That's why you cannot use generation type dot identity in case of table per class strategy. This point is also clear, everyone. So this is one more strategy that actually we have taken. Now talking about the next part. So see, same line is available. Another issue is that you can no longer use identity key generation because it throws the mapping exception. Reason is already told to you. Second thing, if I'm talking about this query, let's say you are writing select EC from electricity connection. So this time, can I say that we are fetching data from the two different tables such that these two different tables are completely unrelated? Yes or no? According to Hibernate, there is a relation, but according to MySQL, there is no relation. Is there any common column? Answer is no. Answer is no, there is no common column. So accordingly, can I say that join operation is not applicable here? And if join operation is not applicable, but listen, if I'm talking about the select query, let's say that if I'm talking about the select query, then into the select query, there are chances that actually I will have some information common. So overall in MySQL, there is one more facility available. This facility is called union operation. What exactly the use of union operation is? The union operation is actually used to join the result of the two different select queries. The join operation is used to combine the result of the two select query. This is what union operation is. So let me write down here that union operation in MySQL is used to combine the result of two different select queries. So this time join cannot be used. If I'm talking about the table per class strategy, then in case of the table per class strategy, union operation is used exactly. Getting my point? Okay. So keep in mind, this is what strategy is. Shall I take a direct example, everyone? I think it will be clear for you if you once see the example. And especially those who did not pay attention to my warning at the end of the class, you have to read the pre-class notes, you have to read the assignments, you have to go through whatever I told you in the class. Those who have followed this advice, hardly 10% scholars, for them, this class is going smooth. Otherwise, 101% chances are there that you people are jumbled, completely jumbled. So the same example I'm going to continue. The same example I'm going to continue. So let me create one class here coming to directly STS. I'm available into the STS. So here, pressing Control N, wanted to create a class. The name of the class that I'm writing is electricity connection. Into the electricity connection class, so definitely I'm writing here two strategies. Thereafter, let's say that I'm using @ID such that @ID is actually working as simple primary key column, but this is not auto increment. But this is not auto increment. Getting my point all? Thereafter, we wanted to generate the constructor. Initially, I am generating constructor from the superclass. Then I am generating constructor from the getter setter method. ID is required because this time it is not auto increment. So ID is required. Thereafter, if I'm talking about the getter setter method, then definitely the getter setter method is also generated here. So first thing, everybody, please take a look at the very first class. The name of the class is called electricity connection class. Please take a look. Giving you a few seconds. And definitely this class is going to be an abstract class. Shall I proceed further? Everyone, shall I proceed further? That's good. Then I wanted to create one more class. Control N. I wanted to create one more class. The name of the class is called domestic electricity connection class. And definitely this domestic electricity connection class is actually subclass of electricity connection. Clicking on finish, and definitely this class is also going to be an entity class. Because this class is an entity class, then if I'm talking about the fields available here, then I wanted to use the field. The name of the field is going to be private double electricity duty. Then they definitely I wanted to generate a constructor from the super class. So initially I'm generating default constructor. After generating the default constructor, I'm talking about generating constructor from the field. So constructor from the field is also generated. Thereafter, I am talking about generating the getter and setter method, selecting all and generating. Please take a look at this domestic electricity connection class. Is that okay? Perfect. That's good. Similarly, I'm going to create one more class. The name of the class is going to be commercial electricity connection class. This commercial electricity connection class is subclass of electricity connection class. And because I need to use the two variables, so definitely both the variables I'm writing here. Thereafter, the entity annotation is something that actually we required. And thereafter, Alt Shift S, then I'm talking about the constructor from the super class. So constructor from the super class is created. Then I wanted to generate the constructor using field. So constructor using the field is also generated. Thereafter, I wanted to generate the getter setter method. So definitely getter setter method is also generated from here. So hierarchy is clear, everybody. This is an example of hierarchical inheritance, such that electricity connection is the top class. Then we are having domestic electricity connection, and then we are having commercial electricity connection. This time, if we are talking about the generation strategy is table per class. Shall I directly try to create object and save them into the database to see if it is working or not? So now I'm talking about the third strategy. The third strategy is going to be simple. We can say that this is table per class strategy. This is going to be table per class strategy, and I wanted to create one method. The name of the method is save electricity and types. Save electricity and types. I think this name is already good for you. Save electricity and types. Copy. So let me create one method. The name of the method I'm writing is static. Then we are writing void save electricity and types. So first of all, everybody, definitely I wanted to create some objects, and initially if I'm talking about some of the lines, then definitely it is good to take some of the lines directly from here. And while taking some of the lines, so initially it will be good to create an object of domestic electricity connection class. Initially it will be good to create some object of domestic electricity connection class. Then we will talk about creating the object of commercial electricity connection class. So here we are writing domestic electricity connection. Let's say I'm writing DEC1 equal to new domestic electricity connection. And whenever we are talking about the domestic electricity connection, then let's say that ID initially I'm providing is 1. You can provide the ID string type also for the differentiation, like domestic connection. It will be DC001. For commercial connection, it will be CC001. This will be a better strategy. Then if I'm talking about, yeah, hello. First thing is going to be ID. Let's say I'm writing 1 unit consumed. Let's say I'm writing 20 per unit charges 10.0. Then I'm talking about taxation percentage. Taxation percentage, let's say we are writing 7.5. This is the first object. And similar to the first object, we are creating the new object also. The name of the new object that I'm writing is DC2 equal to new domestic electricity connection. Writing the ID2 consumption. Let's say I'm writing 50 unit, price 12 rupees, and it is 8.5. Then I'm talking about the commercial electricity connection. Then for the commercial electricity connection, so we are writing CE1, CE1, CE1 equal to new commercial electricity connection. Again, ID, let's say that I'm writing is 3. Unit consumed, let's say that 75. Charges, because it's a commercial connection, so I'm writing 20 rupees. Then I'm talking about duty, it is 77.5%. Fixed charges, let's say it is 30 rupees. All data is just for the simplicity. Then talking about the next part, this is going to be CE2 equal to new commercial electricity connection, ID4, consumption 125, price, let's say we are writing 18 rupees, it is going to be 8.5, and fixed charges 25 rupees. Then it will be good to save the data for DC1. It will be good to save the data for CE1, and it will be good to save the data for this one also. Shall I try to execute this code and see the table structure? So let me come here once, and initially let's say that I am writing show tables before executing the code. Bio student, human maths student, science student, these are the 4 tables available. And let me try to run this code. Right click, run as Java application. Directly I'm coming here. Can you see that how many create table statements are available? 2. The first create table statement is creating a table commercial electricity connection, and second is creating domestic electricity connection. Let us verify on the MySQL. Both tables available? Answer is yes. Let us try to demonstrate the structure of the same. To demonstrate the structure of the same, we are writing DESC, domestic electricity connection, and thereafter the next pointer that we are writing is going to be commercial electricity connection. Can you see the table structure? Separate table for both classes? Yes, it is. Then if I'm talking about the query, let's say that we are writing select star from. Initially, we are talking about the domestic electricity connection. And thereafter, again, we are writing that is select star from. And then I'm talking about the next type of connection. The next type of connection is actually referred as not visible due to my own photographs. So just a second. Yeah, commercial connection. Right click, hitting enter, semicolon. So please check everyone. Please check from STS is that the same data that actually we have inserted here. Yeah, please check. Is it inserting the same data? In the domestic, it is 1, 20, 20, and 7. Sorry, in the domestic, it is 1. Then we are having, oh, might be that, yeah, 1, 10. What went wrong? Okay. This is charges and this is unit charges and unit consume. Yeah, 20, 50, then 10, 12, then 7.5, 8.5. Perfect. In the second ID 3, 4, then we are having 20 is the unit consume, 18 is the unit consume, 75 and 85 is something. Well, columns are slightly jumbled, but overall the data is available here. Shall I try to use the view operation also, like show operation? Shall we try to see the show operations? Yes, definitely. So for the show operations, now coming here, I'm writing here show electricity and type. We are writing the name of the method that is going to be say show electricity and type. So I'm writing here static void show electricity and type. Into the show electricity and type, just for the sake of brevity, some of the portion I am directly copying here and I am pasting directly from here. Persistent context is as it is, inheritance context is as it is. So I'm writing here name of the entity class. So name of the entity class is electricity connection. So I'm writing here select EC from electricity connection. And definitely the result that I'm going to get, it is going to be of the electricity connection type. First query, select EC from electricity connection. Simple JPQL statement it is. Then we are writing select query into the query object. Thereafter, we are getting the result list. After getting the result list, this time the object is going to be of the electricity connection type. The object is going to be of the electricity connection type. So let me give the name EC. If it is electricity connection type, if I'm talking about the common attribute, definitely ID is a common attribute. Thereafter, can I talk about the unit consumed? And after talking about the unit consumed, can I talk about the unit charges? Yes or no? If I'm talking about the specific, then definitely the specific one possible is domestic electricity connection. If it is domestic electricity connection, then for the domestic electricity connection, we can print the actually exercise duty applicable, or let's say that electricity duty applicable on the same. To print the applicable electricity duty, we have to write down get electricity duty here. Similarly, onto the else part, we have to talk about the commercial electricity connection. Again, we are writing commercial electricity connection. For the commercial electricity connection, the data that you can have is what is the value added tax. And apart from the value added tax, you can have one more data such that the name of the data is going to be get fixed charges. Done. Shall I try to execute this query? Just focus on the SQL statements. Specifically, I'm concerned with this select query. I'm concerned with this select query. The select query is somewhat actually bigger for you. It is taking unit charges, etc., etc. Then again, the subquery is also formed there. And apart from forming the subquery, can you see this one, the highlighted area? Union all operation. The union operation is actually used to combine results from the two select query. Now, initially, just talk about the area that is before the union. Before the union all, can you see that it is actually fetching the data from the commercial electricity connection? After union all, it is actually fetching the data from the domestic electricity connection. So union operation is used to fetch and merge the data from the two different things. Union is plain SQL statement. JPQL equivalent is also available. Union is a plain SQL feature. Union is available in all the databases. No problem. No problem. No problem. And can you see this is working as a subquery? Can you see this is working as a subquery? Yes, it is. So Hibernate is very smart. It is managing everything for you. It is managing everything for you. So this is the main operations that actually we were having. So on the console, output was also available, and definitely it will work. So third strategy is all about the table per class strategy. Is that okay? Shall I proceed for the next? And which strategy is to use? It is completely depending on your software requirement specification. In the design phase, according to the demand, you have to decide which strategy to use. Getting my point? There is no best, there is no worst. Everything is depending on the requirement. Everything is depending on the requirement. According to requirement, you have to specify. Now let me talk about the fourth case. If I'm talking about the fourth case, then there is fourth strategy available. This fourth strategy is actually referred as the mapped superclass strategy. Listen, first point. It designates a class whose mapping information is applied to entities that inherit from it. A mapped superclass does not have a separate table defined for it. So listen, last time when I was talking to you about the table per class strategy, then in case of the table per class strategy, I told you that if superclass is abstract class, then there will be no table. But if superclass is concrete class, then table will be there. Remember? In case of mapped superclass, your superclass is not going to have table ever. Your superclass is not going to have the table ever. Getting my point? What is the difference? No matter whether superclass is abstract class, concrete class, interface, whatever it is. If it is mapped superclass, then definitely it is not going to have the table. It designates a class whose mapping information is applied to entities that inherit from it. A mapping superclass does not have separate table defined in it. The annotation that you wanted to use for the superclass is @mapped superclass. One more thing. Whenever you are using @mapped superclass, please do not use @entity annotation along with it. Clear? What is the mean of, what is the restriction with the mapped superclasses? The fourth strategy. First point, it does not have any separate table for itself. Then I'm talking about the next part. The annotation that is used for the same is @map superclass. And please, 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 please do not use @entity annotation with the @mapped superclass. Getting my point? This is one special convention that you should take care. And here actually this factor is going to be seen. If on some annotation there is no @entity annotation, so definitely this object will not be part of the persistent context. Yes or no? Because @entity annotation actually tells the entity manager that please manage it. If on subclass there is no @entity annotation, then definitely this class is not going to be maintained within the persistent context. And if this is not maintained within the persistent context, then do you think JPQL statement will work there? If something is not in the persistent context, then definitely JQL statement will not work there. But there is a catch available. The catch is that normally when we are writing the JPQL statement, so at the time of writing the JPQL statement, we used to write down like from, and after from we need to mention the entity class name. Definitely this actually works in previous three strategies. This is going to work into the previous three strategies, strategies. But this time what you need to do, In case of last strategy, that is the mapped table strategy. In case of mapped superclass strategy, you have to write down from, and after from, you need to write down fully qualified class name of mapped superclass. Fully qualified class name of mapped superclass. This is what actually you need to mention, and this strategy is going to work only for the mapped superclass. So how to write down the JPQL statement for mapped superclass? I hope you are getting some idea. Yes or no? So simple logic. What is the use of @mapped superclass? Whenever you do not want it to create a table for the superclass, then go for the mapped superclass. Simple logic. Whenever you do not want it to create any table for the superclass, then go for the mapped superclass. What is the advantage? No matter whether your superclass is a concrete class, no matter whether your superclass is an abstract class, no table will be generated there. How to use this? The very first point, with the class, you have to use @mapped superclass annotation. And whenever you are using mapped superclass annotation, then definitely you do not have to use @entity annotation. Then that's it. If there is no @entity annotation, then definitely persistent context is not going to manage this entity. Answer is yes. If persistent context is not going to manage this entity, then we cannot write down the JPQL statement using entity class name. Make sense, everybody? So far, all discussion. And if this is the case, then how to write down the JPQL statement? This time you are not supposed to write down the entity class name. Instead of entity class name, you have to mention the fully qualified class name of the mapped superclass. This is the only thing that you have to take care. Getting everyone? Yes, it is. That's great. Shall I directly proceed to take an example? Yes, it is. So initially, now every explanation is done for you, and let me come to the PPT also to check if anything is pending or not. So you can see that while using this strategy, no table is created for the superclass, but for subclass, the table is going to be created. So definitely there will be no polymorphic query. When we are using the term polymorphic query, when you are writing the superclass entity name, but you are getting the data from super and sub both. But no condition is here. No polymorphic query is going to be generated here. So directly I'm going to take example, simple inheritance hierarchy that I'm going to talk to you. For example, let's say that there is a class available. The name of the class is called loan class. Into the loan class, I am having one variable that is called ID. One variable we are having is principal amount. One variable we are having is the time period. And let's say that one variable we are having is the interest rate. This is one class available. Then I'm talking about one more class. The name of the class is called home loan class, such that the home loan class is subclass of loan class. When home loan class is subclass of the loan class, so because it is a home loan, so in case of home loan, we have to pay the stamp duty. Apart from the stamp duty, we may be eligible to take the subsidy. So one variable that I'm writing is stamp duty, and one more variable that I'm writing is going to be subsidy amount. Do you know what is subsidy amount? I think yes. Well, let me explain you in short. Subsidy amount is kind of, you can say, that help that government is giving. Simple logic. For example, let's say that those who are using gas cylinder at the home, do you know that there is no subsidy for the last 2 years? Initially, it was used to be into the bank account, and now it is not available to anyone. So what actually government was saying at that time, that we are purchasing the cylinder at the very high cost, and we are actually providing the same at the lower cost to the public. And how we are giving the same to the public at the lower cost? Because we are giving subsidy. What is the mean of giving subsidy? Some portion of the gas cylinder is being borne by the government. This is what subsidy is. Now getting? Okay. So first part is done. And then everyone, let's say that there is one more class available. And let's say that name of the class is going to be personal loan class. So if I'm talking about the personal loan class, so definitely personal loan is something that is considered to be a matter of luxury. So definitely there is no subsidy available. Another thing that is possible there is we can have a processing fee. Apart from the processing fee, definitely there is add-on taxes are also available. So shall I implement the same hierarchy using the mapped superclass table and see the result? Yes or no? Yes, it is. So see, creating entity classes, etc., you have done for multiple times. So initially, for the sake of time saving, for the sake of time saving, some of the content I have to take from here. Otherwise, we will not be able to cover the syllabus. So just a second, actually coming here, Control N, I'm creating one class. The name of the class that I'm writing is loan class. So loan class is available there. And to the loan class, initially, I am giving you time. Please see if any problem in creating variable and entity class. Shall I proceed? If no problem in just copying pasting the variable of the class, this is required for time saving. So right click, I wanted to generate the constructor from the superclass. So definitely the constructor from the superclass is generated. Then I wanted to generate the constructor using the field. I can generate, this time ID is not required. This time ID is not required. Then I wanted to generate the getter setter method. So definitely the getter setter methods are also done from here. Yeah. So similarly, shall I take one more class? The name of the class is home loan class. Creating one more class. The name of the class I'm calling is home loan class, such that the home loan class is going to be the loan class. It is inheriting the loan class, and definitely this time I have to use @entity annotation. This time I have to use @entity annotation. Then here everybody, again it will be good to use to generate constructor from the superclass because default constructor is required. Thereafter I wanted to generate constructor from the field. This is also done. Then I wanted to generate the getter setter method, and definitely the getter setter method is also done. Please take a look at this class. If any problem, then do let me know. Shall I proceed? Just I'm saving some typing efforts, nothing special. Just I'm saving some typing efforts. Then I'm talking about the next type of loan statements. The next type of loan class is available such that the name of the loan class is called personal loan class. And definitely this is also a subclass of loan class. Then clicking on finish, the class is getting generated. And definitely this time again, I'm going to use the same code. @entity is what I'm writing. Then I wanted to generate the constructor using the superclass. So constructor, default constructor using the superclass is generated. Then constructor from the field is also generated. Thereafter, the getter setter methods are also generated. So 3 classes we have written within the span of 2 minutes. All credit to you that you are actually allow me to do the same. Now, shall I proceed for the save and view operation? Yes, it is. That's good. That's good. Well, actually, one scholar is having some doubt, and this is relevant. So I'm going to take this doubt in the class also. See what happened, why I'm not able to copy. Earlier I was copying. Now, okay. See, the doubt that one scholar is writing, subclass can be with @entity annotation, but abstract class cannot have @entity annotation. This is doubt that is asked by one scholar. So let me come to electricity connection. Can you see that electricity connection class is an abstract class? Still, it is having @entity annotation. So from this example, definitely, if I am talking about the doubt, then can I say that answer is no? Second number point. The reason is that, or the point is that, if your class is having mapped superclass annotation, if your class is having mapped superclass annotation is there, then always keep in mind that mapped superclass annotation as well as entity annotation, definitely they cannot come together. Clear? They are actually complete rivals. They says that we cannot stand into the one podium at the same time. So if you are using entity with the superclass, then definitely you cannot use mapped superclass. Is that okay? So no matter whether superclass is abstract class, concrete class, it doesn't make any difference. You can use entity anywhere. But if you have used mapped superclass, then there is no hope. You cannot use entity. Why you cannot use entity? Because we do not want it to generate the table for the superclass. Now clear? Because we do not want it to get the table for the superclass. That's why. So this part is done. Now let me talk about the next area, and I'm talking about the app.java. Into the app.java, again, let me talk about the two methods. The one method is going to be save loan and its types. One method that exactly I am writing is going to be save loan and types. So let me create one more method. The name of the method is going to be save loan and type. So same method I'm going to copy. And after going to copy the same method, then I'm writing here save loan and type. Copy, paste. Then inheritance connect is same. I think I'm having some objects also for the sake of time saving. Same objects I am using here also. So one object of home loan is created, then one object of personal loan is created here. And definitely then rest of the things are going to be same. So object of home loan is saved here, then definitely object of personal loan is saved here. Shall I try to execute this statement? Once, take your time, you can read, but I don't think there is anything special. Same entity factory, same entity manager is created. After getting the entity manager, home loan object is created, and then we are passing them simple into the persist method. Absolutely similar. That's why I'm doing the copy paste, because typing is unnecessarily consumes so much time that nobody likes, and even I don't like. Run as Java application, and Mr. Console, please come here. So if I'm talking about the create table statement, then into the highlighted portion, can you see there is two create table statement available? The one create table is for the home loan and another create table is available for the personal loan. So let me come here onto the MySQL. Onto the MySQL, if again I am writing show table, then into the show table, you can see that one table is available home loan, one more table is available that is called personal loan. So if I wanted to see the structure of them, right click same, DESC, then definitely right click, paste, hitting enter. So can you see that ID, principal rate, principal amount, time period, they are common. But if I'm talking about the stamp duty and subsidy amount, definitely they are different. So two different tables are generated. There is no table for the superclass such that my superclass is a concrete class. Such that my superclass is a concrete class. Then again, I'm writing that is select star from. So when I'm writing about the select star from, let's say that I'm talking about the first thing. This is called personal loan. Then again, I'm writing here, this is going to be select star from home loan. Semicolon, hitting enter. So can you see that all the data is available here? Into the home loan table, we are having subsidy amount, but into the personal loan table, we have processing fees plus add-on taxes. Insert operation is working 100% okay. Shall I go for the select statement? Okay, so into the select statement, again, there is no logic of unnecessary typing the same thing again and again. Directly, I am coming here and let me copy the example of the show electricity and type. Similar to the show electricity and type, I'm going to write down the next thing. This is going to be show loan and types. This is going to be show loan and types. So copying this show loan and type, thereafter I'm talking about the show loan and type, inheritance connect is there. So this time I'm talking about the loan. So let's say I'm writing this job. Perfect. Shall I proceed further? Then if I'm talking about the type, then definitely here type is going to be loan. Here again, the type is going to be of loan type. And let's say that I'm giving the name loan here. So on the behalf of loan, can I get the ID? Answer is yes. Using the loan, can we get the principal amount? Answer is yes. Using the loan, can I get the time period? Answer is yes. Can we get the interest rate also? Then definitely the answer is going to be yes. Then if I'm talking about the instances, then definitely it can be an instance of home loan. Yes or no? Similarly, otherwise it is going to be an instance of the personal loan. So everyone, something you are missing. Still, I'm giving you time. Something you are missing, please check. Please check, please check, please check. One thing. Now this query is correct. Now this query is correct. Well, my dear scholars, please check these two lines, line number 53 and line number 54. There is no known entity if there is no known entity. So here actually I cannot write down this time loan directly here. This is not an entity. I have to write down the fully qualified class name. And if I'm talking about the fully qualified class name, then the fully qualified class name is going to be com dot Masai School dot inheritance dot hibernate management dot loan. This is something that I have to write down. I was expecting that you will catch it in a very small amount of time, but this doesn't happen. And it's mysterious for me. This is something that is mysterious for me. That's why please pay heed to the class very, very carefully. Otherwise, well, the complete for loop is copied. Shall I execute this query? Right click, run as Java application. Let's see what it is saying. Oh, so much queries are there. But among the so much queries, you can see that two select queries are available, such that the very first query is actually on the home loan table and the second query is on the personal loan table. So definitely because there are two unrelated tables. So in case of the two completely unrelated tables, we will have two different queries. Make sense? Yes, it is. So data is also available to you. Everything is also available for you. So these are the 4 strategies. Now we are going to heading toward the next topic. And before heading toward the next topic, I am giving you 2-minute time period to analyze this slide. Meanwhile, I am drinking some water. Take your time, exactly 2 minutes. Yes, all. So I think this table is kind of self-saving for you. From this table, I think you can compare all the 4 strategies and remember them very, very easily. I think I'm right. Yes or no? Okay, that part is done. So now heading toward the last, but definitely very important part. This very important part is all about the association mapping. See, association mapping is something that is actually a very easy topic. Just you have to remember some of the terminologies with example. just only hardly if you can remember the 2 or 3 examples, then definitely association mapping is really very easy, believe me. Some of the pointers that actually you have to understand. So let me start my discussion. First of all, everyone, you have already gone through the MySQL. Into the MySQL, we have seen multiple different cases. What exactly the multiple different cases are there? For example, let me start with one very basic case, and the entire thing we have used multiple times into the MySQL Sprint 2. Did you remember that there was one table available, category table? Into the category table, we were having the category ID and category name. And there is one more table available. The name of the table was product table, such that into the product table, I was having product ID, we were having product name. Thereafter, we were having many MRP. After the MRP, possibly we were having, I think, MFG date. And after MFG date, there is one more thing available that was category underscore ID. So this time, can I say that one category has many product? Yes or no? Yes, definitely. So by looking at observation, so I'm saying that consider the following table structure. Consider the following table structure. Into this table structure, if I'm talking about the observation, then observation say that one category can have multiple products. One table can have multiple products. In the terms of database, this is actually what referred as one-to-many relationship. This is what actually referred as one-to-many relationship. Sometime you will find that it is written something like that. So please do not read it is 12M. It is 1-to-M relationship. Getting my point? Similarly, if I'm talking about the second observation, then the second observation actually says that, sir, multiple products actually belong to one category. Multiple table actually belong to one category. Can I say that this type of relationship is going to be many to one relationship? Yes or no? Not M21, it is many to one. So if I'm talking about this table structure, then definitely in this table structure, you can see, sir, there are two ways we can see the relationship. From the category side, we can say that this is going to be one-to-many relationship. But from the product side, we can say that this is going to be many-to-one relationship. Make sense? Yes or no? Hurry up. One more observation that I'm going to tell you. Can I say that if I am talking about the foreign key, then definitely the foreign key is always placed on the many side? Yes or no? Foreign key is always placed on the many side because definitely you cannot make product ID a foreign key in the category table. You cannot store multiple values. So better to store the category ID as a foreign key into the product table. So foreign key is always placed on the many side. This point is clear? Yes or no? Yes, it is. Now listen, everyone. There are two terms commonly available. The one term is available such that the term is actually referred as the owning side, and one more term is available such that the term is actually referred as the inverse side. Yeah, one term is available that is called the owning side, and other term is also available that is called inverse side, and the inverse side is actually also referred as the referencing side. Both terms are there, synonym. You can use the inverse side or you can use the term referencing side. Both are going to be work for you. So simple example or simple question I am asking you. Can we have a product without any category? Theoretically answer is no. Yes or no? Yes, it is. So can we say that category is going to be the owning side? Please update your response. We are saying that there can be no product without a category. So definitely category is going to be the owning side. Satisfied with my argument? Everyone satisfied? Very good. Now this argument is incorrect. This argument is 100% incorrect. Why this argument is 100% incorrect? Just listen very carefully. If I'm talking about the table structure, let's say that I am giving you category table. Only from the category table or whatever actually data available into the category table, only from this, do you have any link of the product? Look at the category table and tell me, into the category table, do you have any link to access the product? Answer is no. But if I'm talking about the product table, Then in the product table, I am having a category ID column that is used to establish the connection among the both. So who is the connection holder? Sir, the connection holder is product. So who is actually on the awning side? Product is actually available on the awning side. Getting my point? Clear everybody? How to spot the awning side? Now I am giving you a very simple trick. Many of the time you are using a preposition conjunction, whatever it is, you are using of. If I'm talking about the of, then can I say that O is actually acronym for awning and F is actually the acronym for foreign key. So if you remember this small two-letter word of, then this is going to be a short trick for you. Who is the owner? The awning side is one who is containing the foreign key. Getting my point? How to remember? This is the smallest trick that can be possible there. So never get confused. Who is the owner? It will be decided by the DBMS. It will not be decided by Hibernate. Getting my point? Who is the owner? It will be decided by Hibernate. It will be decided by MySQL. It will not be decided by the Hibernate. So this is the one trick that available. So who is the owner? Awning side. The awning side is definitely the one that has the foreign key. The one that has the foreign key. This is called awning side, and definitely because the name is already referencing side, so name of the referencing side is already clear, the one that is having the primary key. The one that has the primary key. This is the one point available. Let me take one more example. Category product is there. Similarly, let's say that if I am talking about an employee. So for example, let's say that an employee can have multiple bank accounts. An employee can have multiple bank accounts. So second time I am talking to you about one more table structure. Into the table structure, one table that I'm talking to you is employee table. Into the employee table, one thing is available, EID, then name is available, then salary is available, then one more thing is available. We can call it designation, or let's say that we are calling it email. I think three are already more than sufficient. Then I'm talking about one more table. The name of the table is account. Into the account, AID is working as a primary key. Thereafter, let's say that I'm talking about one more column. Name of the column is balance, and definitely as a foreign key, I am talking about the employee underscore ID. Then again, if I am asking you in this condition that who is going to be on the awning side. So please tell me the answer. Which side is awning side and which side is the referencing side? First, tell me about the awning side. Who is the awning side? Hurry up, write your answer. Account. Definitely account is something that you can call the awning side. But on the other hand, if I'm talking about the employee, then definitely employee is considered as referencing side or the inverse side. It is considered as inverse side. So similarly, everyone, if I'm talking about the category and the product case, then into the category and the product case, if I am asking you inverse side, can I say that category is going to be on the inverse side? True or false? Category is on the inverse side. Yes, it is. If I'm talking about the awning side, then definitely product is having the foreign key, and the one that who is having the foreign key, he is available at the awning side. Similarly, last example, it is for one to many, many to one relationship. The last example is that, for example, let's say that if I am talking about a car company, into the car company, let's say that I'm talking about the CID, this is going to be company ID. Apart from the company ID, we are having CNAME. Thereafter, I am talking about the model, such that into the model, there is one thing available that is called MID. Thereafter, price is available. And after the price, then we are having CID. So because one car company can manufacture multiple models, but one model actually belong to only one car company. So in this condition, can I say that awning side is going to be model? Yes or no? Awning side is going to be model because model is having foreign key. Still, I am finding some wrong answers on the chat. Second, if I'm talking about the inverse side, then definitely inverse side is going to be car company. Keep in mind trick of O is for owner, F is for foreign key. O is for owner, F is for foreign key. If you remember the trick of, then definitely this is going to work for you. Awning side is the side that is containing foreign key. Simple concept is there. Clear it is, everyone? What is awning side and what is the yeah, that's good. Now let me talk about the second type of relationship. let me talk about the second type of relationship. Into the second type of relationship, for example, let's say I am talking about one table structure. Into the table structure, I am talking about student. Into the student, for example, let's say we are having roll number is available there, or let's say that we are calling it ID. Thereafter, one more thing is available, name. One more thing is available, that is called email, that is sufficient. Then I am talking about one more is available, that is called course. Into the course, for example, let's say that again I am having ID, or better to use SID, better to use the term CID here. Thereafter, I am talking about course name, and after talking about the course name, I am talking about duration. But this time, if I'm talking about the type of relationship, then definitely one scholar or one student can enroll into multiple courses. Yes or no? Yes, it is. And definitely one course can have multiple students. So can I say this is going to be a many to many relationship? Yes, it is. And whenever you wanted to maintain a many to many relationship, then actually we need a third table. We need a third table. If I'm talking about the third table, then let's say that name of the third table is student underscore course. Into the student underscore course, first column I'm writing is SID. Second column I'm writing is CID. So can I say that the combination of SID and CID will tell us that which student is enrolled in what course, and CID, using CID, we can find out which student or how many students are there. Yes or no? This is many to many relationship. So whenever we are talking about many to many relationships, here again I am writing some observation to you. The observation that I'm writing is that one student can actually enroll to many courses. This is the point number one. The second thing that exactly I am writing is that one course can have many students. One course can have many students. So this time, if I'm talking about the type of the relationship, then this type of relationship is actually referred as many to many relationship. This type of relationship is actually referred as many to many relationship. This is called M2M relationship. Similarly, everybody, this relationship is also referred as many to many relationship from the both sides. So no matter what is your perspective, every time you are going to get the same view. Getting my point? Yes or no? No. Yes, it is. And can I say that an extra table is required to maintain the relation, or to maintain the foreign key, an extra table is required. So this time, everyone, can I say there is no clear candidate for owning side and inverse side? Why? Because we used to say the one who is having the foreign key is the owner. But right now, neither student is having the foreign key nor the course is having the foreign key. So can I say there is no clear candidate for the owner as well as for the inverse? Yes or no? So in this condition, everyone, I will say owning side can be any. Owning side can be any. It is actually depending on the choice of developer. It is depending on the choice of developer. It can be any according to the choice of developer. Getting my point? So you can have a student also, or you can have course also. The same thing is going to be repeated in case of inverse side also. In case of inverse side also, it can be any according to the choice of developer. He can choose student as an owner. He can choose course as an owner. Both things are possible there. So in case of many to many relationship, you are 100% free to decide. Clear it is? Everyone, clear it is? Why so lame response on the chat? Then everyone, I'm talking to you about the third and the last type of table relationship. If I'm talking about the third and the last type of relationship, so for example, let's say that we are having one table. The name of the table that actually we are writing is, let's say, taxpayer table. Or it will be good to write down, let's say that I'm having a table. The name of the table I'm writing is, yeah. So do you know what is the mean of gig workers? Do you know what is the mean of gig workers? Gig workers are kind of freelancers. Simple, you can say that gig workers are simple kind of freelancer. They are not having a permanent job. they used to work for various different companies at different period of time or maybe same period of time. Like I am employee of Masai school. I am not a gig worker. I am a permanent employee. I cannot work with any other organization as per my service agreement. But let's say that if I would be a freelancer, then at the same time I can work for multiple companies. I am a free person. Getting my point? What is a gig worker is? Yes, it is. So for example, let's say that a company is maintaining the data of the gig workers also. So for the gig workers, we are having the gig ID. Apart from that, we are maintaining the name also. Apart from the name, let's say that we are talking about their per day charges. Then everyone, there is one simple logic available. Whenever a company is making payment to any gig worker that is more than of 20,000 rupees, then 10% TDS has to be deducted. And definitely whenever there is a 10% TDS reduction, the TDS will be submitted to the income tax department and company has to provide the PAN number of the gig worker whose TDS has been deducted. Getting my point? Because later on he can claim the same from the income tax at the time of ITR filing. Well, most of the people are here not aware about the ITR related rules. No problem. Then I'm talking about one more thing. The thing that I'm talking about is, let's say there is one table available. The name of the table we are writing is gig worker detail. Into the gig worker detail table, what exactly we have to maintain? For example, let's say that some ID is available, or can I say this time, let's say that we are maintaining information about the PAN card. This time we are mentioning detail about the Aadhaar card. Apart from that, we are talking about the detail of the bank account also. So this time, can I use the same primary key into the both tables? Yes or no? This time, can I use the same primary key for both the tables? Think over it, because when gig worker is going to have only one PAN card, definitely there will be combination of one PAN, Aadhaar and bank. It is going to be unique. And definitely every gig worker is having the same. So can I say this is an example of one-to-one relationship? Yes or no? Can I say this is an example of one-to-one relationship? It is 121. And if I'm talking about the one-to-one relationship, then in case of one-to-one relationship, and this is maintained actually from the both side. Let me talk about one more example. Let me talk about one more example. There is one table available. The name of the table is called question table. Into the question table, I am having question ID. And after the question ID, let's say that I am having question language that I am calling is question text. If it is a descriptive question and such that I am saying that there is one ideal answer for this question. There is one ideal answer for this question, such that question and answer they are maintained into the separate table. In this case, everybody, I am having two strategies. One strategy, similarly, I should maintain one answer ID. After answer ID, I should maintain the question ID. And thereafter, I should talk to you about the ideal answer. Table structure seems okay? Yes or no? Everyone, table structure seems okay? Yes, it is. So listen, and this time, let me change the situation. The situation that I'm changing is I am saying if I am removing the answer ID column, still it is not bothering me because there is only one ideal answer for one question. So if I'm using question ID as a primary key in the both tables, then still my job is done. Yes or no? Think over it. Visible? So this type of relationship is called one-to-one relationship. This type of relationship is actually referred as one-to-one relationship. Getting my point? Yes or no? Now clear? Yes, it is. So simple logic. Whenever I'm talking about one-to-one relationship, then we are having concept of common foreign key. We are having concept of common primary key means the same table is working as primary key here. The same table is working as primary key plus foreign key here. But on the other hand, whenever I'm talking about the one-to-many relationship, then definitely foreign key will always be available on the many side. Getting my point? Foreign key will always be available on the many side. Yes, it is. And whenever I am talking about many-to-many relationship, then definitely there is a third table available. Because there is third table, so nobody is actually owning the foreign key. That's why we can say that this time you are free to decide which is going to be a primary or which is going to be a foreign, or which is going to be owning side and which is going to be the inverse side. Getting or not? Yes or no? And here in this condition, in this table structure, can we say that it is good to use question as inverse side, but answer as awning side. Yes or no? Because into the answer, this column is working as primary plus foreign both. Getting my point? Your same column is working as primary key for the answer table, but this primary key for the answer table is referencing the primary key of the question table. So single table or single column is working as primary plus foreign both. That's why if I am asking you that which one is going to be on the awning side, then definitely your answer is that sir question is going to be on the awning side. And if I'm talking about the, sorry, answer is going to be on the awning side. And if I'm talking about the question, then definitely question will be available on the inverse side. Make sense, everyone? The same thing is going to be here. If I'm talking about the gig worker detail, then this is containing the foreign key. So this is the owner. On the other hand, if I'm talking about only gig workers, this is going to be the inverse side or referencing side. Shall I proceed further? Okay, so awning side, referencing side, this is the first point that should be clear to you. If it is clear in your mind, then you can assume that 90% of the association mapping is done. 90% of the association mapping is done, because this is the only thing where people are confused most. But I think this discussion is already sufficient, and the trick of is always savior for you. Okay, now let me proceed. And while proceeding, initially, let's say that I'm talking about the example of employee and account. If I wanted to use the same thing into the Hibernate, then definitely to use the same thing into the Hibernate, first of all, I have to create an entity class such that the name of the entity class will be employee. Yes or no? I have to create an entity class. The name of the entity class is going to be employee. Then can I say that this column is going to be ID and this is going to be my entity class? Answer is yes. Apart from this, can I say that I am talking about the name? And apart from talking about the name, I am talking about the email address also. This is the first structure. Similarly, I am talking about another entity class. The name of the entity class is called account class. Into the account class, let's say that I'm making it a primary key. Then if I'm talking about the balance, then let's say that balance is going to be of type double. If I'm talking about employee ID, if I'm talking about employee ID, now the question arises that, sir, how to maintain this employee ID? Some options I'm giving you. First option, maintain the employee ID in the form of integer because it is containing foreign key, and such that the foreign key is going to be integer value. Seems reasonable? Yes or no? Yes, it looks reasonable, but you should never do this. But you should never do this. If I'm talking about the correct way, then the correct way is that everyone, you must always use object, because Java says employee is an entity in itself. Employee is related to account entity, and because we are in Hibernate, so chances are there that you might wanted to access account detail using employee object. And if the account detail is available, then you may wanted to access employee detail also. If employee object I am embedding here, then definitely using the account only, I will be able to access employee also. Make sense? Because in Hibernate, you are not writing the query. Whenever there is an object available, then for this object, query generation is actually done by the Hibernate. Did you remember lazy loading, eager loading that we have discussed yesterday in the example of has a relationship? Third one, default customer. Okay. Here actually it seems that it is getting embedded. Practically it is not getting embedded. I have not used @embedded annotation. I have not used @embedded annotation. So what is take place here? Here at the domain level or at the Java level, what exactly we are finding? That sir, account object is containing employee object. Accordingly, sir, there are chances that actually the account table is going to contain all the detail of the employee also. My answer is no. My answer is no. Why answer is no? Am I dealing with the has a relationship here? Am I using @embedded annotation here? Answer is no. Getting? So this is not the case. This is not the case. Second number case. If I am using employee here, then definitely it is the Hibernate's responsibility to join the table and to fill the data of the employee here. But as we have already used annotation in the previous cases, similarly here I have to use the annotations also, and I have to tell Hibernate what kind of relationship they are having. Getting my point? what kind of relationship they are having, I have to tell them explicitly. So from the account side, from the account side, can I say that the relationship is going to be many to one relationship? Yes or no? Because one employee can have multiple accounts. Make sense, everyone? One employee can have multiple accounts. So from the account side, this is going to be many to one relationship. And to depict this many to one relationship, there is one annotation available. The annotation is called @many to one annotation. Getting my point? Yes or no? How I am telling the Hibernate that this employee object is representing the many side. Sorry, this employee object is used to create the association, and it is telling that many accounts belong to one employee. Now, can you interpret this? Many account belong to one employee. This is what exactly message it is conveying. So right now you will say that, sir, okay, from the account we are able to access employee, but if I'm talking about the employee class, then from the employee class we do not have anything to access about the account. Yes or no? Practically it is. So there is one thing you have to create. You have to use actually one more annotation, and the name of the annotation is going to be one to many annotation. And because one employee can have many accounts, that's why here I have to maintain a set of accounts. If I'm going by this practice, then can I say practically I am actually maintaining a bi-directional relationship? Why bi-directional relationship? Because using the employee, I can access account, and using the account, I can access employee. Yes or no? Behind the scene, your database structure will be same. Now your Hibernate is responsible for managing all the data into the domain model. So don't you think that you do not have to do anything? Your table structure is as it is, but Hibernate is providing you a lot of facilities. Of course. So this is called association mapping. This is called association mapping. So this is the first case that actually I have taken for you. Definitely we will take all the examples, don't worry. We will take all the examples, don't worry. This is the first case that I have told you. Now let me come to the PPT ones. When two DB tables are in a relationship, then definitely their JPA persistence classes must be designed and configured supporting that relationship. This is called association mapping. Already discussed, yes or no? Second number point, we have four types of association mappings. They are one-to-one, many-to-one, one-to-many, and many-to-many. For the first three types of mapping, the first three types of mapping are one-to-one, many-to-one, and one-to-many. Two tables are enough, that are the parent and child table. But to define the many-to-many association, three tables are required. Already covered? Yes or no? Yes, it is. If I'm talking about the loading behavior, then in the loading behavior, you can say that one-to-one and many-to-one, they are having eager loading. So can I say any relationship that is ending with the word one, it is having eager loading? Yes or no? The relationship that is ending with the word one, it is having eager loading. Simple trick. Make sense? And any relationship that is ending with the many, it is having lazy loading. Simple. Now can you remember this? Any relationship that is ending with the word one, it is actually eager loading. And any relationship that is ending with the word many, it is simple lazy loading. This is what actually you have to remember. Then if I'm talking about the owning side and the referencing side, so you can say that the owning side of the relation is the side of the relation that owns the foreign key, and the other table that is being pointed is referred as the inverse entity, or this is what actually refers as the referencing side. Same trick of already discussed. Yes or no? Yes, it is. That's good. There is a long example available. You can refer to this example, but I have already done with my explanation, so I'm not going to repeat it again. Then you can see that JPA relationship can be of two types. It is going to be either unidirectional or it is going to be bidirectional. It simply means that we can model them as an attribute of one of the association entities or both. For bidirectional relationship, we define both the owning side and inversing side, both the side. Into the unidirectional, we are defining only on the owning side. We are defining only on the owning side. A detailed example of the both type of relationship we are going to take. Detailed example of both of them we are going to take. But one more thing that I wanted to tell you. See, the owning side is one, that is containing the foreign key. Whenever you are actually available onto the awning side, then you have to use one annotation. The name of the annotation is going to be @join column annotation. The name of the annotation will be join column annotation. Again, simplifying. Simple question. Simple question. Awning side and invert side, is that clear? I think yes. So whenever I am talking about awning side, then which annotation I have to use? Join column. Can you remember this? Whenever I am talking about awning side, then definitely I have to talk about join column. O for awning, J for joining, join column, and you can remember OJ platform is already there. You can relate somewhat like this also. So the join column annotation actually define the actual physical mapping on the awning side. To make this association bidirectional, all we have to do is to define the referencing side. So listen what exactly I am going to do. @join column, in this condition, I have to specify here, make sense, because this is the awning side, account side. @join column, I have to write on the awning side in the employee and account example, who is the awning side? Account. I have to write down join column where? In the awning side, that is account. First point clear? Yes or no? I will take final summarization also, don't worry. And whenever you are writing join column, then actually you have to write down name of the column that is going to work as a foreign key. So can I say that employee ID is name of the foreign key column? Can I say employee underscore ID is name of the foreign key column? Yes or no? Second annotation is also available. Now, this time I am available at the inverse side. Yes or no? When I am available at the inverse side, then I have to use one more attribute. The name of the attribute is called mapped by attribute. And into the mapped by attribute, you have to write down the field name that is used for association. Please take a look, everyone. Read this. Don't worry. Read this. Don't worry. Take a look at this example. Take a look at this example. Again, one by one. Again, one by one. First of all, employee is the inverse side and account is the awning side. First point clear to everyone. I'm moving step by step. Final summarization it is. Employee is the inverse side, account is the awning side. This point is clear because account table is containing the foreign key. From the account side, this is going to be the many to one relationship. Make sense? From the inverse side, it is going to be one to many relationship. Make sense? What type of relationship I wanted to build? I wanted to build bidirectional relationship. What is the mean of bidirectional relationship? From the employee, I can access account, and from the account, I can access employee. Meaning of bidirectional relationship is clear. From the one entity, you can access the another entity. This is what bidirectional relationship is. Whenever you are writing bidirectional relationship, then definitely you have to use @join column, such that @join column must be written on the awning side. This is clear. @join column must be on the awning side. And whenever you are using @join column, then you have to specify physical name of the column that is working as foreign key. Clear? It is actually containing name of the foreign key column that is used to create the association. Explicitly, you are telling that what name exactly we are going to use. Okay. Then when it comes to the inverse side, because we are talking about the bidirectional relationship, then with one to many annotation, or actually with all the annotation, there is one attribute available. The name of the attribute is called mapped by attribute. This mapped by attribute does not have any concern with the database. It says, please provide name of the field of the awning entity that is used to create the association. Please provide name of the field from the awning entity that is used to create the annotation. Getting my point? With the mapped by, you have to use field name. With the join column, you have to use column name. Clear this point? Slightly confused? 60-70%? No problem, no problem. We will take example also. But before taking example, it will be good to go for a break because you people are actually slightly getting confused as well as exhausted. So 8 minutes. Don't worry, you will get relaxed, then or I will explain it again. Pausing. Yes, everyone. So, shall I summarize everything that I told you? I think it will be the only good thing that I can do initially for you. Rest is a matter of practice. See, some pointers that actually will be good to discuss. First of all, definitely the awning side is one that actually that contains the foreign key. This is something that we already know. And definitely the other side is actually called inverse side, or apart from the inverse side, you are actually calling the same as referencing side. These are the two things that are available for you. Next thing, if I'm talking about the bidirectional association, if I'm talking about the bidirectional association, then always keep in mind in bidirectional association, both the awning side as well as the inversing side, they are having variables for each other. Yes or no? In case of bidirectional relationship, we are saying that both sides have actually variables of each other. It can be in any form. It can be in the form of collection. It can be in the form of plain object. Both possibilities are there. Third thing, third thing. If I'm talking about at the rate join column annotation, then definitely at the rate join column annotation is to be used at the at the at the to be used at the awning side such that its name attribute contains the name of the name of the foreign key column. Just follow step by step. Then I'm talking about the fourth part. The fourth part is that the mapped by attribute of the mapped by attribute of the any annotation. You can say that at the rate 1 to 1, or you can call at the rate 1 to many, or you can call at the rate many to many. In all the cases, the mapped by attribute of 1 to many, or you can say that 1 to 1 or 1 to 1, and many to many annotation is used to contains the field that is field from awning side that actually maintains relation. These 4 points, please read and then refer to the code. Again, giving you 2 minutes extra. Have you done with all the 4 points? Shall I proceed? Take an example. Yes, it is these 4 points you should remember. Definitely they will help you a lot. So I'm going to create one. Better to create a separate project because this project is containing everything about the inheritance mapping. So file operation, wanted to create a new Maven project, and the name of the Maven project that I'm giving you is called, first of all, I have to apply the Maven archetype quick start. Hurry up, hurry up, hurry up, hurry up, hurry up. Yeah, Maven archetype quick start. And then name I'm writing is, this is going to be association underscore mapping underscore example. Okay. Into the association mapping example, it is asking that whether you wanted to create the project in the interactive mode. Hurry up. Yes, I am agree. Everything is okay. Hurry up. Generate this. Done. Thereafter, into the association mapping, you know it very well. The first part is actually to remove the unnecessary dependencies and to upgrade the Java version. So Java version we are rating is 1.7. Then for the dependencies, two dependencies are something that we use so much. One of the dependency is MySQL connector, and other dependency is also there, that is called, one dependency is MySQL connector and one dependency is Hibernate. Both the dependencies are added. After adding both the dependencies, then I have to copy this src slash main slash this one. So let me copy. No, src slash main slash resources. Okay. So within the src, within the main, first of all, I have to create a new folder. The name of the folder is going to be resources folder. Within the resources folder, we have to copy the meta inf, and within the meta inf, we have to talk about the persistence.xml. So this time, if I'm talking about the name of the database, then definitely name of database I have to specify here. So normally I used to keep the database name same as whatever be my project name is. So in this condition, I'm talking about this is going to be association mapping example. Then coming to database, and while coming to database, I'm talking create database, and name of database is association mapping example. Then I'm talking about use association mapping example again. Then definitely if I'm talking about the show tables, then definitely table is empty. Then moving toward the last step from the app.java, let's say that I do not want anything into the app.java. Oops, I do not want anything into the app.java. Then done. Now coming to Java, app folder is available there. The very first thing, I wanted to create a class. The name of the class is going to be employee class. The name of the class is going to be employee class. Remaining files that are not useful, I'm closing them. Loan, home loan, personal loan, persistence.xml. This is also almost done, no problem. App.java, I may require it sometime of previous project. Yeah. So first of all, everyone, I'm into the mapping example and src Java folder. First, I wanted to create a class. The name of the class that I'm writing is employee class. So for the employee class, I'm going to copy some of the content. So first annotation that I'm going to use is @entity annotation. After the @entity annotation, let's say that I'm available here. What happened? Project is not updated. Right click, Maven, update project, then updating the project. Okay, done. Right now, perfect. Again, perfect. If you wanted to generate the primary key, then definitely we are having the generated value. Into the generated value, we have to talk about the strategy. And for the strategy, it will be good to talk about the generation type. And definitely the value is going to be the generation type dot identity. Then into the import statement, we have to write down the same thing here. Done. Generation type dot identity. Okay, now perfect. So I'm having one class employee. Into the employee class, ID is there, name is there, email is there. Then because I'm talking about the one-to-many relationship, so definitely one-to-many annotation I have to use. And while using the one-to-many annotation, I'm using the mapped by also. Second thing, I have to create one class. The name of the class is going to be the account class, and into the account class, again we have to write down first of all @entity annotation. After writing @entity annotation, then these are the variables that are required for us. So first variable is ID, second we are writing is balance, then definitely one to many is available, join column is available, employee ID is available. First part I have done. Set is I have to import. Okay, set is imported here. Thereafter, Alt Shift S, I wanted to generate initially the default constructor. So default constructor is generated. Then I wanted to generate the constructor from the field. Definitely ID is auto increment. It is not required. So generating the constructor. After generating everything, then I wanted to generate the getter and setter method. Let's say that the getter setter method is generated for all. Done. Same thing I have to perform here. Same thing I have to perform here. Definitely the variables are required to be private. Here also into the employee class, if variable is not private, then you can make them private. But main target is to learn about the association mapping. Okay, this part is done. Coming to account class, and into the account class, I wanted to generate constructor from the superclass. Yes, constructor is generated from the superclass. Generate the constructor from the field. ID is auto increment, not required. Then I'm talking about the next part, such that the next part is going to be my getter setter method. So getter setter method is something I have generated. Two entity classes I have generated here. One entity class is employee and second entity class is simple account class. So first of all, everyone, if you people have any ask in this code, please do let me know. If everything is okay, then write one on the chat. I will go for insert and view operation. If everything is okay, then I will go for insert and view operation. Yet definitely it is a matter of practice. You have to make mistakes, then you will learn how exactly mapping is working. But these pointers that I'm giving you, definitely they will be extremely helpful for you. Definitely they will be extremely helpful for you. So one part actually we have done. Then actually some jobs I'm going to do. First of all, write code to add the employee and account using object. Okay, I have to open file that is app.java. So right now I'm coming into the app.java, and while coming into the app.java, so everyone, I think this is already known to you that entity factory manager is a heavy object and entity manager factory is a heavy object. So definitely it is good to create only one for the same, and to create one for the same, it is good to use the static block. Yes or no? Yes, it is. And coming to the file, the name of the file is persistence.xml file. Into the persistence.xml file, what is the name of here? Oh, let me change the name here. This is going to be association connection. Copy this name, coming to app and taking this. Thereafter, can I create a method that is static entity manager? And then we are writing here that is get entity manager here. While writing the get entity manager here, I am writing here return, and then I am writing here emf dot create entity manager. Done. After writing create entity manager, so these two codes or these two lines, now there is no need to create the entity manager factory every time. Directly I have to use the get entity manager method and I am done. Now I am talking about one method. The name of the method I am writing is static void. The name that I am writing is add employee and account. See, now there is a very simple point I am asking you. Just based on the common sense, please answer. Without saving inverse side, can I save the awning side? Question is, without saving inverse side, can I save the awning side? Answer is 100% no, definitely, because actually, if there is no primary key available, how you can insert the value into the foreign key column? Make sense? If there is no primary key available, then how you can insert the value into the foreign key column? This is not possible. That's good. So always keep in mind that we have to apply save operation onto the persist side first or onto the inverse side first. Now, let me create object of employee. So I am creating object of employee. I am writing employee emp1 equal to, then we are writing here new employee. So into the employee, for example, let's say that for the employee, I have to set name and then I have to set the email also. So I'm writing here emp1 dot set name. For example, let's say that name I'm writing is ABC. Thereafter, we are talking about the mail ID. Definitely, this is going to be abc@gmail.com. One employee I have created. Similarly, everyone, I wanted to create some account object. Create some object of accounts. And definitely to create some object of account, I am writing here account acc1 equal to new account. Account acc1 equal to new account. And for this account balance, first I am calling the set balance method. Whatever be the spelling mistake, let it be continue. For example, let's say that balance, for example, I'm writing, let's say it's 15,000 rupees. One object of account is created. Similar to this, I'm creating one more object, and this object is I'm writing account 2. For the account 2, initially the balance that I'm writing is going to be 9500. And take a look at the entity. To make this entity complete, definitely I have provided value for name. I have provided value for email, but I have not provided value for the accounts. Similarly, if I'm talking about the account entity, into the account entity, value for the balance is provided, but value for employee is not provided. So this time you will say that, sir, providing value for employee is very, very easy. Why this is very, very easy? Because we are having EMP1 already. Makes sense. Similarly, here we can have MP1. Makes sense. Perfect. No problem. But everyone, if I wanted to set employee set for of the accounts, then first of all, I am writing here set account set equal to new hash set. And into this hash set, initially I am actually adding the first account. The name I am giving is ACC1. Thereafter, I am giving the second account. The name actually I am giving is ACC2. Then using the EMP1, I am calling the set account method, and into the set account method, I am passing set. So how to fill all the data? Is that okay? How to fill all the data? Is that clear, everyone? Thanks for the correction. No, I have to write down EMP1. No? Why to modify? One employee, two accounts. Unnecessary confusion. One employee, two accounts. Getting line number 39 is not an error. It's perfect. I am writing ACC2. Sorry. Yeah, now better. Okay. So everyone, can I say now all the data for employee is also filled and all the data for account is also filled? Yes or no? This time, can I say that all the data for the account is also filled, all the data for employee is also filled? Make sense? Finally, it is good time to take the transaction, then definitely to save the employee and then to save the account. Clear? So I wanted to take the entity manager. To take the entity manager, there is a method available. The name of the method is called get entity manager method. So first copy this get entity manager here. And I'm writing here, this is going to be entity manager, EM equal to get entity manager. Then definitely it will be good to get the transaction. And whenever we are getting the transaction, then from the transaction, actually we are getting the ET, such that this is going to be entity transaction. After having the entity transaction, then definitely ET dot begin is the first method we have to call. Then ET dot commit method is something we have to call. Then finally, it will be good to close the same. Now listen, I'm discussing the two situations to you. I'm discussing two situations to you and they are very interesting. If I'm talking about the first situation, then definitely the first situation is that using EM. Initially, I am calling the persist method, and while calling the persist method, initially I am saving the employee. So definitely this will actually execute the insert query on the employee table. Yes or no? It will actually execute the insert query into the employee table. Thereafter, it will be good to save the first account. Then it will be good to save the second account. Yes or no? Clear, everyone? How this will proceed? This is the first way available, and this is called the conventional way. This is called the conventional way, but listen, let's say that if an employee is having 10 accounts, then would you love to write down the persist method for the 10 time? No. Similarly, in case of many-to-many relationship, let's say that one scholar is enrolled into 5 courses and one course is having 29 students. Then would you love to do the same job? Answer is no. So actually, ORM is there to serve you. So into the ORM, there is one very good thing available that is going to save you. If I'm talking about the inverse side, then inverse side is employee. Inverse side is employee. Here actually everybody, one more option I am writing. This is called cascade operation. And for the cascade operation, the value that I'm writing is cascade type dot all. What is the mean of this cascade is? First of all, if I'm talking about the literal mean of cascade, then simple you can say that cascade is kind of synonym of chain. It is simple kind of synonym of chain. And when I'm writing cascade type dot all, it means if I am deleting an employee, then its corresponding account will be deleted automatically by the ORM. First point clear? Similarly, if I'm changing the primary key of an employee, then in all the accounts, this primary key or the foreign key will be changed automatically. Similarly, if I'm writing cascade type dot all, if I'm saving the employee entity, then all associated account entity will also be saved automatically. Clear it is? What is the mean of cascading is? So this time you can say thanks to ORM. Do not need to write down everything again and again. If your data is completely filled, then all the data will be saved. See, if I'm talking about the cascade type, then cascade type is just an enumeration. Into this enumeration, we are having some values. One value you can see persist. Second value is called merge. Third value is called remove. Fourth is refresh. And fifth is called detach. If I'm talking about persist value, persist means only for insert operation. Whenever you are saving an employee, then its corresponding account will be saved. Getting? For persist operation only. When you are saving an employee, then its account will be saved. Remaining operation does not have any concern. Similarly, if I'm talking about merge, if your employee is getting updated, its corresponding account will be updated. For the remove, if you are removing an employee, its corresponding account will be removed. But remaining operation does not have any concern. If you want all these facilities together into one, then there is a value available called cascade type dot all. Clear? So this time, if you are adding an employee, corresponding account will be added. If you are deleting an employee, corresponding accounts will be deleted, and everything will be managed by the ORM for you. Do not need to run here and there. Clear, everyone? How this is so much useful. So this time, because cascade type equal to all, that's why insert employee, it will save account also. Is that okay? It will save account also because we have used cascade type dot all. I think this will help you to remember the things in a better manner. Make sense? Shall I try to run this code? So copy, then I'm coming here and paste, then saving this part. And let me try to run this code running as Java application. Oh, that's good. Some exception is there finally. Okay. Let me check what exactly went wrong. Going to the account. Actually, onto the ID. I did not apply the generation type primate. I forgot to apply this strategy here. That's why actually the mix-up actually takes place. For the employee, generation strategy is automatically. For the account, there is no generation strategy. But actually the problem is that if I'm talking about the show tables, then I think tables are created. So let me drop the table. First, I have to drop the table account. Then I have to drop the table. The name of the table that I'm calling is employee. Both the tables are dropped. Now your application is perfectly new. Coming here, right click, run as Java application. Yeah, no exception. First table account is created, second table employee is created. And can you see that into the insert query? Two insert queries are there for the account. Can you observe this? Two insert query for the account. Can you observe this? Yes, it is. Now let me come here into the MySQL. Again, let's say if I'm writing show tables, yes, this is perfect. Then I'm talking about the first table. The name of the table is called account. And next table is available. The name of the table, first table is employee. The next table is account. ID is there, email is there, name is there. Can you say that employee ID is working as a foreign key? Simple one-to-many relationship? Yes or no? Then if I'm writing select star from employee, and then I'm writing here select star from account. Working, everyone? Yes or no? Please check the data. Okay. Okay. Similarly, everyone, can we write down the query to view the record also? Answer is yes. And this time actually something observable will happen. This time something observable will happen. Why are you not doing by dynamic way? You can take input and you can do. Who stopped you? My target is not to take input. My target is to teach you how to association is working. That's all. So then I'm talking about show employee and account is one I have created. This time, if I wanted to get the entity manager, then definitely to get the entity manager, directly there is a method available. The name of the method is called actually get entity manager method. After writing into the entity manager method, I can create the query from here also. And why exactly doing so much hard work? Can I directly use the find method? And into the find method, I am talking about the employee.class and employee ID that exactly I am writing is 1. Definitely, this is going to give me an object of employee. Definitely, this is going to give me an object of employee. Once everyone, an object of employee is available to me, then definitely if I wanted to print the detail about the employee, if I wanted to print the detail about the employee, then for the EMP, can we print the ID? Answer is yes. For the EMP, can we print the name? Answer is yes. For the EMP, can I print the email? Answer is yes. So simple question I am asking you, has I fetch any information about the accounts? Am I trying to fetch any information about the account? Answer is no. Right click, run as Java application. Where is the error? Where is the error? Initially, oops. Hmm. Now right click, run as Java application. And when I'm running the same in the form of a Java application, please take a look at the select query and do let me know if this select query is working on the account table or not. Take a look at this query and do let me know if this is fetching data only from the employee table or it is fetching data from both the tables. Option 1 from the employee table only, option 2 from both the tables. Only from the first, definitely only from the first. Now let me do one more job. The thing that exactly I am doing is everyone. Let's say that I wanted to print the account details also. And to print the account detail, we are writing here set account set equal to emp dot get accounts. And when we are writing emp dot get accounts, so definitely this is a set available. And on this set, we can iterate the loop. And while iterating the loop, if you wanted to print the account detail, then definitely you can print the same also. So for example, I'm writing here sec dot get id. After get id that I wanted to print acc dot get balance. After balance, if you wanted to print anything, you can. Now again, see, listen very carefully. I am fetching the employee detail. Then I am printing the employee detail. After printing the employee detail, then I wanted to fetch the account detail. Then I wanted to fetch the account detail. I am running the same using the Java application. Can you see? This is clearly a case of lazy loading. Why? Because when I am writing the find method, then it is fetching the data only from the employee table. Yes or no? And it is fetching data from the account table only when get accounts method is called. Make sense for you that whenever I'm using one too many, so one too many, it is ending with many. And because it is ending with many, so it is going for lazy loading. Clear? Verified? Yes, it is. Similarly, everyone, let's say I'm doing the opposite side because this is a bidirectional relationship. And definitely in case of the bidirectional relationship, we can go opposite side also. This time I'm saying that first you have to fetch the account and from the account detail, then you have to show the employee. Get entity manager is there. This time I'm talking about account. This time I'm talking about account. So, okay. Initially, I'm fetching the detail of account. When I'm fetching the detail of account, then definitely using this account. If I wanted to print the ID, I can print. If I wanted to print the balance, I can print. This time, am I printing anything about employee? Am I printing anything about employee? Answer is 100% no. Because answer is 100% no, everyone. So let's say this time I am calling the show account and employee method, right click, run as Java application. And when I'm talking about the Java application, please take a look at the query. Can you see this is a clear case of eager loading? Yes, it is. Because for the account, it is many to one relationship. And whatever relationship that is ending with the word one, for them, there is eager loading. Both cases verified? Yes or no? Now, no matter whether you are printing the employee detail or not, it is fetching. no matter whether you are printing the employee detail or not, it is actually fetching. If you wanted to print, then definitely you can print. So overall, this is an example of here actually you will find that there is a eager loading available. On the other hand, at the top side, here actually if I'm talking about the type of loading, then definitely the type of loading is going to be lazy loading. First example, okay everybody, how to maintain the bidirectional relationship. I hope this is okay for all. Just as matter of practice, you have to do a lot of practice because it takes some time to get cemented. Shall I take one more example, everyone, of many to many? This time slightly into the speedy manner. My God, the batch is getting depressed. The batch is getting depressed. Okay, well, so if I'm talking about the example of many to many relationship, then for many to many relationship, I would love to take a simple case for you. If I'm talking about the case of student and batch, then definitely this is something I can take very, very easily. So let me create some classes. Control N, I'm talking about one class. The name of the class I'm writing is student class. See, code is going to be very, very small. Don't worry. First annotation is @ entity annotation. Second annotation is going to be @ ID annotation. Then definitely generation strategy is something I am happy with. So generation strategy is also there. Thereafter, I am writing here, this is going to be that is private string name. Only this information I am maintaining. Only this information I am maintaining. Then I am talking about one more class. The name of the class that I am writing is course class. Name of the class that I am writing is course class. Into this course class also, I am talking about ID here. And definitely this is also going to be an entity. Simple logic. Simple logic I am asking you. Can I say that one student can have multiple courses and one course can have multiple students? According to this principle, can I say that I have to maintain a set of students here? Yes or no? Everyone, can I say that I have to maintain a set of students here? Similarly, like I am maintaining a set of students here. On the same ground, can I maintain a set of course here also? Yes or no? Can I maintain a set of course also? Yes or no? Yes, it is. This time because it is one to many relationship. So I'm free to choose anyone as a owning side and I'm free to choose anyone as a inverse side. It's my choice. It's my choice. And this time everybody, do you know that a third table is going to be created? Yes or no? Because this is many to many relationships, third table is going to be created. Now listen everyone, whenever you are talking about this third table relationship, then in case of the third table relationship, first of all, see, if I'm talking about the annotation, is it good to use many to many annotation? Yes or no? Both side. Both side I have to use many to many annotation, perfect. And one more thing, I have to specify the join column. So definitely to specify the join column, actually there is one more annotation available, join table annotation. The join table annotation actually allow you to specify the name of the resultant table. It allow you to specify the name of the resultant table. So if I'm talking about the name of the resultant table, the name of the resultant table I am writing is student underscore course. Actually, the primary key is coming from both the sides. Because the primary key is actually coming from both the sides, so definitely I have to specify them also. To specify the same thing, there is one attribute available. The name of the attribute is called join column, and one more attribute is available. The name of the attribute is actually called the inverse join column. If I'm talking about the join column, then again I have to write down the join column. Into the join column name equal to, no sorry, into the join column, I have to mention reference column name. Both primary keys are having the name ID. Both primary keys are having the name ID. So same line I have to specify at both places. This time, what is the rule? Please try to understand. First of all, first parameter is clear that I'm talking about name of the generated table. First point clear. Into this table, there will be two columns available. First column will be primary key from the student table and second column will be primary key from the course table. Both the things I am specifying using the join column and using the join inverse column. This is one thing that actually you have to do additionally. If you have done the two jobs, everyone, then definitely you can generate constructor from the superclass. Done. You can generate the constructor using the field also. After generating the constructor from the field also, then you can generate the getter setter method. And after generating the getter setter method, zoom panels again on top. Yeah, this part is done for you. The only mysterious thing is this one, nothing else. Then talking here course part, again I have to use many to one association. And when I'm writing here many to one here, so see, student is actually containing joint table. Because student is containing joint table, so can I say that student is going to be the owning side? Read this line. The line that I given you, read this line. Can I say that at the rate joint column annotation is actually to be used at the owning side? According to this principle, can I say that student table is actually working as primary table because joint column annotation, joint table is used here? Yes or no? If this is the owning side, then definitely on the inverse side, I have to use mapped by attribute also. Into the mapped by attribute, I have to specify the name of the field that is used to create the association. Make sense, everyone? You can make honor anyone. You can make course honor. You can make student honor. It's completely your choice. It's completely your choice. And nobody is going to ask you that make this person honor. No, almost nobody is going to ask you. So stay relaxed. Stay relaxed. Then I'm talking about generating the constructor. Okay, constructor is being generated. And actually, I forgot to include the course name also. Otherwise, how will actually we will identify? So I am writing private string course name here, and it's a string value. So definitely it will be good to use the same course name here. Then I'm writing here that is this dot course name equal to course name. Then coming here, we are talking about generating the getter setter method. So for the getter setter method, they are generated here. Well, both the entities are done. Both the entities are done. Finally, shall I take an example of insert statement? Going to app.java. Shall I take an example of insert query? Yes, it is. See, topic is not tough. If you remember the 4 or 5 pointers that I have given you, then life will be easy for you. Rest is again. So I'm talking about save student and course. See, student is the owning side. Student is the owning side. So definitely again, I have to save the student first. Yes or no? Because without student, I will not be able to actually create the relation. Practically, I have to save both. But who is on the owning side? On the owning side is student. So can I say that it will be good to use cascade type here, such that the value of cascade type I need to write down is going to be cascade dot all. No zoom interface on my side now available. Okay. Actually, for some time, zoom interface was completely off. So I thought I'm disconnected. Okay, I'm writing cascade.all. Coming to app.java file. Into the app.java file, first of all, I'm saying that create object of students. So I'm writing here student. Then I'm writing here st1 equal to new student. Then for the student, it will be good to save some data. And if I'm talking about data, so let's say that I'm talking about set name. Name of the student that I'm writing is, let's say it's st1. Thereafter, next thing that I wanted to set is set course, but there is no object for the course so far. So first part is done. Then I'm creating one more object. Name of the object that I'm writing is st2. Name of the student, again I'm writing is st2 here. Name of the student that I'm writing is st2 here. After doing this part, everyone, right now, how many students I'm having? I'm having 2 students. Okay. Then I'm talking about some courses. So I'm writing course CR1 equal to new course. This is the first point. Then for the course, it will be good to save the name. So let's say that I'm setting the name, setting the course name. Let's say this is Java. Then I'm creating one more course. Name of the course that I'm writing is course 2. And name of the second course that exactly I'm writing is going to be MERN. Thereafter, one more course is available to you. The name of the course is actually called the CR3. And if I'm talking about the CR3, then for the CR3, let's say that I'm writing the name Python. Better to create a set of student also. Better to create a set of student also. See, into this set, I am adding the first student, that is ST1. After adding the first student, then I am adding the ST2 also. Similarly, I am creating a set of courses also. So I am writing here CR set equal to new. Again, I am talking about hash set. Again, I am talking about hash set. After talking about hash set, then I wanted to add CR3. Similar to CR3, I am adding CR2. After adding CR2, then I am talking about adding the CR1. All the three things are added here. So listen everyone, so far. How many students are there? 2. How many courses are there? 3. Now how I am going to set the things, just try to understand. For the ST1, I am writing set course into the set course for the student 1. Can I say that for both the students, all the 3 courses are applicable? Yes or no? For both the students, all the 3 courses are available because I have to fill the complete data. So if I'm calling the set student into the set student for the course 1, all 3, for the course 2, all 3, and for the course 3, again all 3. Done. So, well, so much content, but by mistake, app.java is closed. Hmm. So this time, everyone, all the data is properly stuffed. Once all the data is properly stuffed, then isn't it good that if I save st1 and then I save st2, then it is going to work for me? Yes or no? If I save st1 and st2, then it is going to work for me. Let me try. Let me try. Save and right click, run as Java application. Any exception? Answer is no. Any exception? Created student, one more table is created. The name of the table is called, that is student course. So I'm coming here and directly it will be good to write down, that is select star from course. Then I'm writing here the next query is going to be select star from student. Then I'm writing one more query. The name of the query is going to be select star from student underscore course. Might be I forgot to save the name for this, but this time, can you see that actually both the scholars are actually enrolled in every course and their relationship is maintained here? Yes or no? And if I'm talking about the type of loading, both the times we are having many to many relationship. So for the many to many relationship, can you tell me what type of loading it will be? Lazy or eager? Definitely lazy, because both relationships are actually ending with many. Clear everyone? So I'm not writing the example, but just one thing for you. Shall I provide you one complete example that is kind of same example, or actually 100% same example, in which I'm having example of one-to-one relationship also, and I'm having example of unidirectional relationship also. Would you love to have this? Every comment is written here, everything is written there properly. In this example, we are having one-to-many, many-to-one bidirectional. We are having many-to-many bidirectional. We are having one-to-one bidirectional. Apart from this, many-to-one unidirectional, one-to-many unidirectional is also there. Regarding the unidirectional, later, one scholar is writing later. Do you have classes later on? Simple logic. Simple logic. Listen, please. Let's say everyone, let's say, if I am removing this part, just actually focus for only 1 or 2 more minutes. Let's say from the employee and account, from the employee and account, let's say that if I am removing this part. Now, can you say this is a unidirectional relationship? Yes or no? Yes, it is. And can I say this unidirectional relationship is of type many to one? Yes or no? Yes, it is. This time using the account object, I can access the employee. Yes or no? But using the employee, I cannot access account. Now understand why this is unidirectional. Second case. Let's say that I have removed employee information from account. This time, again, can I say this is a unidirectional relationship? Can I say this is a one-to-many unidirectional relationship? Using the employee, can I access account? Answer is yes. Using the account, can I access employee? Answer is no. This is what unidirectional relationship is. This is what unidirectional relationship is. In case of bidirectional, we are having variables on the both side. In case of unidirectional, we are having variable on the one side. Clear, everyone? This is the only thing that you have to take care. That's why I am saying that I will provide you an example. In that example, everything is there. Unnecessary, if I'm taking one class for this, then definitely your PSC will be gone. So what is your choice? Option number 1, PSC. Option number 2, you want regular class tomorrow. I think PSC is more important because definitely you are actually not very much comfortable today for this. Tomorrow, if you are getting the revision, then definitely it will be good. But tomorrow in the PSC, I will ask Anand to include one example of unidirectional mapping. Now, will it be okay? Tomorrow in the PSC, if Anand give you an example, then I think it will be okay. But everyone, tomorrow's PSC will be meaningful for you only if you please study it very, very carefully. This is very important for your evaluation point of view also. Okay, you are very good in reading between the lines. So I hope you are getting what I want to say. Tomorrow, make sure be into the PSC. That's all from my side. I wish all the best for your future. Rest. Bye bye. Stop.